Good noon, everyone. Today discuss about CAPS computer-aided process synthesis. Unit number 4, synthesis of heat exchange and networking. આ યુનિટ મોસ્ટ ઇમ્પોર્ટન્ટ છે, જેમાં 28 માર્ક્સનો કવર અપ થાય છે જીટી એક્ઝામમાં. This is the most important theory. Today discuss about the minimum number of heat exchangers. અને 7 માર્ક્સ ઇન જીટીયુ એક્ઝામ 3 થી 4 વાર પૂછાઈ ગયો છે, રિપીટેડ ક્વેશ્ચન્સ છે. એના પ્રીવિયસ લેક્ચરમાં આપણે કોમ્પોઝાઇટ કર્વ મેથડ જોયું હતું. Then after minimum networking then network for maximum energy recovery part जो હતો. Okay, તો સ્ટાર્ટ કરીએ. મિનિમમ નંબર ઓફ હીટ એક્સચેન્જર. Having a design for a heat exchanger networking part, the meets for a maximum energy recovery in targets. It is common to reduce the number of heat exchanger also, and the two words the minimum while permitting the consumptions of utilities to rise. Utilities यानी कि some different processes and different flow diagram for any simulation and optimization part for a computer-aided process synthesis. Some programming, linear programming also. Okay, this is having designed a heat exchanger networking. That means the maximum energy requirements for a target. It is common to reduce the number of heat exchanger also towards the minimum while permitting the consumption utilities, some processes to rise, and particularly when small heat exchanger can be eliminated. Okay, it is a way for a lower analyzed the cost to be maybe obtained, especially when the cost of the fuel is a low relative to the purchase cost of the heat exchanger. Okay, low relatives in the purchase in this quality. Okay, and alternatively an attempt can be made to design the heat exchanger networking to minimize the number of heat exchanger and satisfy the maximum energy recovery target by involving the stream splitting or objective part in a heat exchanger networking synthesis, यानी कि hence for a different method or minimum utility targets, temperature interval method, grand composite curve method. Okay, then after the pinch design approach is the inventing a networks. Okay, then after a network for a maximum energy recovery. Then after discuss about the main point today, minimum number of exchanger. Okay, this is the most stream splitting આપણે જોવાના છે. નેક્સ્ટ લેક્ચરમાં જોઈશું ડિટેલમાં. ઓકે, then after the having this design for a heat exchange networking for this simply sub point part, reducing the numbers of heat exchanger and breaking heat loops. Okay, they having designed for a heat exchanger networking meet are the maximum energy targets recovery target. It is common to the reduce the number of heat exchanger towards the minimum while performing the consumptions of any utilities. And some process જોવાના છે, ડિટેલ્સમાં આપણે ડિસ્કસ કરીશું. And particularly when the small heat exchanger can be eliminated in these ways for a lower analyzed cost may be obtained, especially when the cost of the fuel is a low relative to the purchases, the cost of the heat exchanger also. Alternatively, an attempt can be made to design for heat exchanger networking to minimum the number of the heat exchanger and the satisfied the maximum energy recovery targeted requirement to by involving the stream splitting. Okay, then after reducing the number of heat exchanger, breaking heat loops for discussion part is there. Before the any processing, it is important to recognize that as a point out by Homan 1971 find a scientist name, the minimum number of the heat exchanger in a heat exchanger networking systems is a most important equations in a business પર discussion કરવાના છે. This one as a n heat x nx nhx minimum is equal to ns plus nu minus 1. So what is the ns and what is the nu? The ns is a number of streams and nu is a number of total or districts hot and cold utility, hot and cold utility ના સોર્સ જે આપણે grand composite curve ના મેથડ પર જોયો હતો. This one is simply a graphical basis. In the cold phase, hot phase જે H1 to H2 અને ઇનલેટ આઉટલેટ માટે અને C1 to C2 જે કોલ્ડ ફેઝ ઇનલેટ અને આઉટલેટ બંને માટે હતું એ જોયું હતું આપણે. Okay, for again repeated part, for before this processing, it is important to recognize that as pointed out by the Homan, this scientist name, as the 1917 find out this year, and the minimum number of the heat exchanger is a HEN, heat exchanger networking. Okay, and this is the equations. NHX minimum is equal to NS plus NU minus 1. So where NS is the number of streams NS and NU is the total number of distinct hot and cold utility sources. Okay, hot and cold utilities છે. The four hot utilities fuel stream at high pressure यानी कि HPS. Okay, thus for hot utilities यानी कि some processes જેમાં fuel streams high pressure હશે is a simple short form is a HPS, this one. Okay, and then the intermediate pressure यानी कि IPS, intermediate pressure IPS in the low pressure यानी कि LPS. And for cold utilities boiler feed water यानी कि BFW, cooling water CW, and these refrigeration each count as distinct any utilities processes. Okay, याद रखो most important. So what is NS, number of streams, NU, number of hot and cold utilities sources. Also hot utilities fuel streams high pressures यानी कि HPS, intermediate pressure IPS, LPS यानी कि low pressures, BFW यानी कि boiler feed water, CW यानी कि cooling water. For refrigerations each count as the distinct any utility sources. Okay, and hence for the networking example is the 10.7 and 10.8 આપણે જોઈશું, and which involve the 4 streams and 2 utility streams and the cooling part for NHX minimum is equal to 5, equation number 10.13, this one. NHX minimum is equal to NS plus NU minus 1, details માં જોયું આપણે. And that indicates that the minimum number of heat exchanging in a heat exchanger and with the minimum capital cost of the heat exchanger networking increase with each distinct utility sources and they utilize in a design the however as shown in a section 10.8 part, and the operating cost of the heat exchanger networking are reduced by the replacing a portion of the utility and a duty requirement provided by a costly utility and a refrigeration part by one of the lower cost, for example cooling water. Okay, then in a more general result for this scientist named Douglas 1988, so that the minimum number of heat exchanger it is also dependent number of independent networking for N and W, that is the number of the sub networking consisting the link path between the connected stream માટે છે. And what is the important equations is there, this one. NHX minimum is equal to NS plus NU minus N and W. Starting માં શું હતું only minus 1. Okay, NS plus NU NHX minimum. Okay, where the all stream is process are connected is directly and indirectly for heat exchanger as in a figure 10.19a જે નીચેના પાર્ટમાં છે, બધી ફિગર જોવાની છે આપણે. heat exchanger networking involving a network source માટે જે independent networking છે. અને 10.20 નો પાર્ટ છે the 3 heat loops in the heat exchanger networking. Okay, for n nw is equal to 1 for equation 10.14 જે બહુ જોયું આપણે અને equation 10.13 for nhx minimum is equal to 4. Nothing that the heat exchanger is a figure 19 10.19a has a 7 heat exchanger. There is the excess of the minimum possibilities in a contract 19b figure માં જોઈશું and illustrate a network for 5 streams and two utilities process છે. 5 સ્ટ્રીમ આપી છે અને 2 યુટિલિટીઝની પ્રોસેસ આપી છે. Okay, and two utilities comprise of the two independent sources यानी कि subsystem, one connecting the stream hot phase and a cold one phase, and the cold utilities are the second connecting streams H2, C2 and C3, and the hot utilities in these cases for NHX minimum is equal to NS plus NU minus NW. એટલે બધાની વેલ્યુઝ છે આપણી પાસે is equal to 5 plus 2 minus 2 is equal to 5. So which is the number of the heat exchanger in the heat exchanger networking shown this one. Okay, in one of the first studies of the method for a heat and integrations for a 1917 માં જે હોમન્સના સાયન્ટિસ્ટ છે એને ફાઇન્ડ આઉટ કર્યું હતું. and the heat exchanger networking यानी कि NHX heat exchanger NHX minus NX minimum independent heat loop exists, that is a sub networking that exhibits cycles heat flows between the two or more streams. The simplest case of a heat loop is shown in a figure, and the 10.20a nothing the streams H1 and C1 are the method twice with heat exchanger 1 and 3. A similar heat loop is shown in a figure in a 10.20b. Juo 10.20b parts is there. Okay, this is a pinch point. Okay, heat exchanger cold phase આપેલો છે અને આ બાજુ hot phase છે. Okay, then more discussion part is there. 10.20b and where heat flows the between stream H1 and C2 is 2 matches. In the heat exchanger 2 or 4, a more complex heat loop is shown in a figure 10.20c in which heat flows between the streams H1 and C1 in the heat exchanger loops. Okay, in the between the H1 and C2 in the heat exchanger 2 part, and the between C1 and C2 and the hot utility is forming a closed heat cycle. Not that this if C1 and C2 were to be serviced by two methods. Discussion part is there. Okay, almost more figure is there. Main figure part is there. Jo one network માં ટાઈપ છે. ફર્સ્ટ વન એ ફિગર આપી છે, સેકન્ડ બી આપી છે તે ટુ ઇન્ડિપેન્ડન્ટ નેટવર્કિંગ. ઓકે, એમાં ટુ નેટવર્ક્સના કનેક્ટેડ આપેલા છે. ઓકે, હવે 10.20માં બી જુઓ. there to 3 heat loops in the heat exchanger networking. ફર્સ્ટમાં જુઓ પિંચ પોઈન્ટ, એમાં ટુ નેટવર્કિંગ છે, આમાં બે ટુ નેટવર્કિંગ પાર્ટ આપેલા છે, આમાં સિંગલ નેટવર્કિંગ પાર્ટ્સ. ઓકે, then distinguished source of the hot utility, there is a would be not heat loop in the figure 10.20c, not also that 3 heat loops infinitely figure 10.20. For explanation part is there why the heat exchanger networking has 3 heat exchanger for NH maximum minimum માટે. Okay, and since the pinch exists in the figure 10.20 for a heat exchanger networking, that means the maximum energy requirement targets consist of two independent networking or one of the side of the pinch, so that NH n plus HX minimum part, and the NHX is equal to NS plus NU minus n HX minimum. Okay, the 1 is equal to 3 plus 1 minus 1 is equal to 3. Nothing that is positive and negative subscripts indicate the hot and a cold side માટે છે. For respectively, there's a heat exchanger networking in this figure already discussion part is there, and there is in bracket 1 maximum energy requirement for nhx minimum is equal to n plus nhx minimum plus nhx negative part is equal to 6. The simplest change 2 is eliminated heat exchanger 1 and transforming its duty to the heat exchanger 2 part, decreasing the duty of the heater on one stream C2 by the amount of in the increasing the duty of the heater on stream C1 by this amount. This is the referred as to the loop for breaking upon the smallest heat exchanger in the heat loop is eliminated because the cost of the area saved by eliminating a small exchanger is usually more than the cost incurred in increasing the area of a large exchanger by the same amount. Okay, and the already discussion part is there as well as be shown in example 10.9. Each heat loops broken by removing a heat exchanger and the heat loads accordingly for a heat exchanger networking, uh, maximum energy requirement, also pinch point, design pinch point, removing any heat exchanger networking away from the its maximum energy requirement targets. Okay, so thank you so much. Next lecture માં આપણે ડિસ્કશન કરીશું some regarding example અને theories. Thank you so much.